Okay, hey folks. I've got the normally aspirated engine stand back online. I still have the turbo stand. It's working perfect. The one thing I had to rob from it to make this work was the battery. I don't have an extra 12-volt battery laying around, so I can't start and run both engines at the same time. But that's okay. I was waiting on a fuel pump because the fuel pump I had, a spare I got from some God knows where, it was just bad, wide open, so that was no good. So I just got the fuel pump in, cheap, like 35 bucks, you know, not that bad. And all the wiring's done. But I want to show you, I want to go over the wiring. Remember, the main thing I did to this stand was I just recommissioned it by going through all the wiring and making sure everything was cleaned up. I learned a lot from the other stand. I'm trying to up my game a little bit by doing a little bit better job of my work. So let's start with some of the enhancements. If you look carefully, you'll see a lot of these wire looms. Okay. So what I did was I relocated the voltage regulator down on this side. It's not hooked up, but all the wire colors connect, so it's just a direct, you know, black to white, yellow to yellow kind of connection. I'm waiting for a certain kind of 5-pin round connector I had to get from China, of all places. It's on a slow boat from China, I guess. So we're waiting for that to come in. But that just means the alternator won't charge, but other than that, it'll run fine. There's the new fuel pump, which is exactly like the old one, just for, you know, I was able to just get a replacement. The gas can was interesting. I'm cheap, okay? It's just the way it is. And you can't believe how hard it is to find just a standard red gas can without all the fancy carb, you know, emission approved fueling, blah, 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 blah. So I took an old motor oil can and recommissioned it by poking a couple holes for the feed and return line, which I use clear vinyl because there's no pressure on either one of those lines. And it lets me monitor the fuel coming out of the can and being returned to the can. I think that's kind of a cool idea. So I have a main body harness that takes care of the one instrument now. I have the harness also goes to the regulator, the starter, the alternator. There's a feed right here that goes to the oil sending unit. Okay, it wraps around underneath. So rather than going underneath the engine like it did before, it comes around the front of the engine. It feeds the distributor. I've got the electronic module there. I couldn't get, that's some kind of proprietary, that's not a standard plug. I don't know what that is, so I just ended up using spade leads and just being done with it. I'm going to make a color code chart, make sure it's handy and stuck there so anybody ever has to figure out what's going on. If it came unplugged, you could re-plug it back in. I have a single cable now that I made that basically goes from this 4-pin connector right here, which comes off the EFI harness, and goes over to the ignition switch and other stuff. But basically there's a whole bunch of wires there that are gone now. I cleaned up all those grounds that were stuck on that one bolt. It has a single ground now. But all this was done because I was unhappy with the way it all looked underneath there. You have to look at some earlier ones, you'll see what I'm talking about. I'm still going to end up, I'm going to mount this better. I'm going to try to mount this ECU in a shock-proof container. I'm going to mount these resistors, dropping resistors out of the way. I'm going to mount these EFI and fuel pump relay. I'll probably bolt them up. Again, I'm just trying to clear out the underneath space so it's not so crowded underneath there. You'll notice I put a copper sheet where that char was taking place, so that won't char anymore. I've got a brand new muffler. The one I had on there was out of the old Z, it was all blown to hell, so that was cheap, you know, like 25 bucks. Hooked it up, it's real nice and clean, neat. That's a Thrush turbo muffler, I believe it was. It's 2-inch inlet outlet. They just call it 2-inch. I can't remember if it's inside diameter or outside diameter. They just say 2-inch. 2-slice pizza. As far as making it work, when I do this, when I completely rewired it, I want to make sure everything works right. So let's talk about that a little bit. This is where your test equipment comes from. Right? This here, that's a high current test lamp. It's basically a tail light or both filaments gang together, and you put about 4 or 5 amp load on the system. You've got a standard test light, 100 milliamp, I don't know, not much. That's for low current visual confirmation of voltage, and of course a digital volt ohm meter. I use that primarily for checking resistance. I don't like using this to check voltage. I mean, it's okay to check voltage if you just want to get a gross number, but if you want to test the circuit, you're better off, in my opinion, using those test lights because it puts a load on the circuit. If you have a high resistance something or other, it's not good. Also, what I like about this is I put it on the tone for continuity. That makes it easy to check continuity, and I'll talk about that in just a minute. Before you even fire this thing up, before I even plugged in the ECU, because on this system, the fuel pump works independent of the ECU, as does the ignition. You can completely disconnect the ECU and crank the engine and check the operation of the fuel pump and the spark to make sure it's sparking. So I did that after I got everything, before I even plugged in the ECU. Again, it's the turbo, there's some interaction between the two. This one, that's not the case. It completely be unplugged, you can check spark, and you can check the fuel pump. So I do that, make sure that I put this high current light in place of the fuel pump, because I don't want the fuel pump running dry. And so make sure that lights up when it's supposed to. You do that by turning the key switch to on or pressing the airflow vane. For everything else, and the spark's easy. You just see if you hook up a spark plug and see if you see anything. This is what I want to talk about. In the factory service manual, you've got several pages, starting right here, for instance, and you just go through every one of these pages. Like, for instance, this one was the circuit that was highlighted in bold was the throttle valve switch. That's a 3-position switch, and it tells you the pin out at the 35-pin connector, which is what connects up to the ECU, and what it does. In this case, it's a continuity check. So when the throttle's at idle, you should have continuity on pins 2 and 18 of the ECU. So I would use the audio check, set to audio, and I go to pins 2 and 18. Now see, I even have that little copper wire. I hope you can see that. That's a probe. I put it into the connector. The ECU the ECU itself is disconnected. Remember, you're connecting to the naked connector, and make sure you get continuity. Now, what was important about that particular test was when I did it, I made a note that I had an intermittent contact. That is, as I throttle up and down, you're supposed to have either short go away, short come on, short go away. Short. It wasn't always working right. And as it turned out, it had an intermittent connection right here. You could touch this and make the tone go on and off. So this connector was not good. I pulled that off, sprayed some deoxit, cleaned it up, put it back together, all good to go. But that's why you have to do this stuff. There's no ODB on these old engines. You are the ODB. Okay, you have a service manual and you need to use this thing. Go through every single one of these pages. I had a check mark. I did the throttle valve on high. When you throttle up, it was working, the tone's working fine. The next one here looks like it was a check for what is the resistance across the airflow meter at pins 6 and 8 of the ECU. All right, I noted what it was. 6 and 8 is 226 ohms. So you go back to the service manual, it'll give you an approximate resistance reading when that's appropriate. Sometimes it's a resistance reading, sometimes a continuity, sometimes it's a voltage. Every one of these I go through, and this is pins 7 and 8. As you move the airflow meter, the resistance should go up. It did. It started out at 200 and it goes up. That tells me I have a good functioning airflow meter. Next one was like just a solid resistor. That's some kind of a part of the voltage divider circuit. It's got 125 ohms. Again, you go back, you make note of what you're reading at pins 8 and 9, and you get the appropriate. You write down what you get, and you go back and check. You go through all these pages, okay, all of them, And when you get done, you've checked out every system that the EFI has. So anyway, let me continue my dissertation on EFI. So anyway, I went through that, and I do that for two reasons. A, I want the system to work, but more importantly, I want to make sure that when I've hooked up all my sensors and I've got things running and I've hooked up all the cabling right, I haven't done anything stupid, okay? You want to make sure you haven't done anything stupid, you're going to have smoke in your ECU, especially when it comes to what pins on the ECU are supposed to be grounded. There's a whole bunch of them. They're grounds. They're basically grounds for all the injectors, and which ones are supposed to be a power. You know, you're supposed to have power to the ECU. You wouldn't want to be putting 12 volts to something that's supposed to be a sensor, you know, something like that. So it's important that when you're making the connections, and there's that one plug down there. That's the main ECU connector. It goes to the inside body of the car, not the one that plugs into the actual ECU box, but the one that plugs into the body parts of the car. That's what you're emulating with the system, and you make sure you've got that right. I think there was a switched power, there was an always power, there was a start signal from the ignition switch, and there was one other, I can't remember what it was. Oh, and the last one was the pump relay output to the pump. So those 4 wires have to be connected up right and going to the right places before you plug in your ECU and fry it. So anyway, that was the whole point of going through this check to make sure everything worked like it was supposed to. All the voltages were where they were supposed to be, all the grounds were where they were supposed to be, and all the signal inputs were appropriate for what they should have been. Anyway, after I did that, then I tested to make sure. I had a few leaks. Here, I'll show you that. That was interesting. Again, because the fuel can be run independently of the ECU, before I did anything, I confirmed that I did have a leak. I had a bad fuel. I actually had a bad fuel line here. It was spraying gas everywhere. So, yes, I had proper protection, so I didn't spray myself. I had to replace that fuel line. I'm going to go through the wire harness. Right now, it's covered up with this split loom stuff. I'm going to probably take all that off, make sure all the wire links. You'll see I made one lead too long here. I'll make sure all the wire leads are the correct length, and then I'll rebind it up. But that was just to kind of keep it organized and give me some kind of a roadmap of how I wanted things to work. But anyway, it's all done. And that being said, fuel in it, coolant. Let's see if I can embarrass myself with a crank no start situation, or if it'll just go. I started a little while ago, so it's kind of a warm start now. Everything's hooked up. You see what I mean about the fuel return? You see you've got no motor to the fuel line. Sometimes when you start them, after they've been run for a little bit, and it kind of can take a few seconds for everything to settle down. But as you can see, my oil pressure reading, my temp is coming up slowly. So my instrumentation is good. Like I said, right now the alternator is not hooked up, so there's nothing I can do about that, but the voltage is just draining down. That's how it works. And you see it's nice and quiet. That muffler really deadens the noise. And there you have it. Anyway, I hope you enjoyed that. And I hope that inspires some people to build an engine run stand. They're really convenient for when you're messing with something and you want to debug it. I personally, if I was doing an engine swap, I wouldn't even consider put an engine into a car. Let me make sure it's plugged in properly. I gotta look at vacuum leads. A person wouldn't even consider putting an engine into a car until I run it on an engine stand and I know everything's gonna work exactly as I want it to, because it's a lot easier to deal with an issue when it's outside of the car than once it's inside the engine compartment. Anyway, thanks for watching. Hope you enjoyed it. That's all. Bye.